Hello everyone, welcome to the channel. I'm Masoud, and today I'm going to talk about distributed system, and this is the first episode of a long series about distributed system. But don't worry, I'll explain it in simple and with real world examples. Many developers work with distributed systems in every single day, but a few truly understand what's happening underneath, and this series is truly about this very simple question. So, if you are wondering things like, I don't know how big websites stay online even when servers crash, or how your data stays consistent across many machines, or why concepts like leader election replication, multi-leader replication, leaderless replication, or quorum, or consensus even exist, and how tools like Kafka, Redis cluster, MongoDB, or Kubernetes work internally, I promise that this series is perfect for you. And today I'm going to start with the most basic question of all: what exactly is a distributed system? Let's start with a simple analogy. Imagine you open a nice and small ice cream shop. One worker scoops the ice cream, one worker takes the money, and one worker washes the cups. Everything is simple, one shop and one place. But all of a sudden, your shop goes viral on TikTok. People love it. They line up around the block, and you can handle all the traffic. As a result, you open a second shop, then the third, and then the fourth, maybe in another city. But all the shops need to have the same flavor, serve the customers fast, and keep working even if one shop has a problem, and feel like one brand. Even they are in different locations, customers experience this as a one unified ice cream company. This is exactly how distributed systems work. Each shop is a server or is a node, and all your shops is like a system, a unified system. That's it. That's a basic idea. That's the foundation of a distributed system. But now the question is, what exactly is a distributed system in a technical term? So let's start it and see it from the point of view of the genius here. Leslie Lamport. It's a kind of funny definition. A distributed system is a system in which the failure of a computer that you didn't even know existed can render your own computer unusable. This is a very fun and simple definition of a distributed system. I really like it, but this is a more technical and formalized definition of a distributed system. Actually, a distributed system is a group of independent computers, usually called nodes, that work together to look like one single system to the user, just like your nice ice cream shop. And here, computers might be a PC, might be a laptop, might be a phone or a watch, or everything like this. The key here is that we have a group of independent computers in a abstract definition of a computer that work together, but from the point of view of the users, they are just look like one single system. Google search is not one computer, it's thousands. Netflix streaming is delivered by hundreds of servers, and Amazon's route to request via many servers. But to you as a user, it feels like one website or one server. This is the basic idea of a distributed system. The core idea is multiple machine behaves like one machine. So now the question is, why do we need distributed systems? There are three main reasons here. One is that one server cannot handle millions of users. It cannot handle billions of requests. So as a result, we have to add more servers. Instead of making one server bigger, we add more servers, and this is called horizontally scaling. So the first reason is scalability. In a distributed systems, nodes fail, hardware dies, or machines crash. It happens all day, And if one machine crashes, another one should continue the work, and your website cannot disappear. Distributed systems helps to prevent downtime, and this is what's called high availability in a distributed system. Users live everywhere around the world, Africa, America, Asia, and if the servers are in one country, so it will be slow for many users. As a result, companies place their servers in multiple countries. So the third reason is geographic distribution, and that's why CDNs exist in distributed systems. Distributed systems come with many problems and difficulties, but the big one, I think, is failure, and it's normal in a distributed system. And keep in mind that in a distributed system, something is always broken. Packet gets locked, clocks drifted, servers fail, hardware fail, or the data centers lose power. And yeah, in a distributed system, something is always broken. And it's not an exception, it's normal in a distributed system. It should be an expectation actually in a distributed system. This is why distributed system and designing distributed system is hard. It's hard not because of code, not because of algorithms, but because of the failure that is the essence of a distributed system. That's why designing distributed system is really hard. And to overcome this big issue, failure, and scale easily, many modern distributed systems use an architecture called share nothing. This means every machine has its own CPU, its own RAM, its own DC, and its own network, and machines or nodes only communicate with each other via sending messages. And no machines depends on another machine's internal disk or CPU or RAM. The machines are working totally independently. This is the architecture used by Kafka, Cassandra, Redis cluster, Raft, Paxos, DynamoDB, and it's very simple but really powerful. And don't worry, I'll delve into these topics in the upcoming series. But the promise of a distributed system is trying to balance between these four big goals: consistency, availability, performance, and fault tolerance. Availability means the system should keep working even if one machine fails. Performance refers to the fact that the system as a whole should be fast. And fault tolerance means the system should continue working even if something went wrong or even if something breaks. To achieve this, we use concepts like cap theorem, leader election, replication, consensus algorithms, quorum, vector clocks. But don't worry, I'll explain all of these concepts in the upcoming episodes. But now let's look at some real examples that we already know. The first one is Redis. Redis cluster Redis can run on multiple nodes. One is the leader or the master. If a leader dies, another replica will automatically become the next leader. Kafka topic replication has the same architecture. One is the leader that overwrites the goes into that node. The leader handles write, and replica copy the log. It's a type of log-based replication. If the leader dies, a replica takes over. In a MongoDB replica set, there is one primary and a set of secondaries. If the primary fails, another secondary will become the primary. And you can see a pattern, or a pattern emerges here. One leader and a set of followers, and I'll discuss all of these patterns in the upcoming series. Okay, well, to recap, a distributed system is many independent machines that working together to achieve tolerating failures and keeping data consistent and providing a single unified experience to their users. This is the foundation for modern technology. Okay, in the next episode, I'll talk about why designing distributed systems are hard, and I talk about failures, partition, replication, clocks, and cap theorem. Thanks for watching. Make sure you subscribe, like the video, and stay tuned for the episode 2.